Hey everyone, welcome back to another explainer. Today, we're diving into something that is literally rewiring how modern systems operate, real-time data architectures, specifically stream processing. If you've ever wondered how massive global systems handle unimaginable volumes of data without even breaking a sweat, well, you're in exactly the right place. We're going to break down the core mechanics of stream processing today, so get ready for a fast-paced, highly practical session. Let's kick things off with a question. Have you ever wondered how your bank can process a credit card swipe and flag it for fraud in like mere milliseconds? I mean, they're definitely not waiting for some nightly batch job to run while you're just standing there at the register, right? The old way of doing things meant waiting until tomorrow to actually see today's data. But in our interconnected world today, that kind of delay is a total deal breaker. We absolutely need systems that react continuously, right here, right now. So here's our roadmap for today. First, the shift to continuous data. Second, managing state and joins. Third, windows, time, and ordering. Fourth, real-world fraud detection. And fifth, the future of data. Let's get into it. All right, Section 1, the shift to continuous data.
Okay, so the absolutely crucial point here is grasping the difference between batch and stream processing. In the old, kind of comfortable world of batch processing, data is bounded. You've got a fixed input, say exactly 1 day's worth of server logs. And because it's fixed, you know exactly when it ends. That means you can sort it, crunch the numbers, and spit out a result. But stream processing, it completely flips the script. Streams are unbounded. They're infinite. The data literally never stops arriving. And here's the kicker, events often show up totally out of order. So instead of waiting around for a predefined batch, you're continuously handling events the very second they arrive. Now, there's this really fascinating mathematical analogy that perfectly explains the relationship between data streams and databases. Think back to calculus for a second. Application state, like a standard table on a database, is basically what you get when you integrate an event stream over time. And on the flip side, a change stream is the derivative of that state by time. So what does this actually mean? It shows us that a change log isn't just some random byproduct. It is the literal evolution of state over time. Mutable state and an append-only log of immutable events, they're really just two sides of the exact same coin.
Moving right along to Section 2, managing state and joins. And this brings us to a real game changer, stateful processing. You see, a simple stateless stream processor just looks at one single event, maybe filters it and passes it right along. But if you want to build truly powerful stream pipelines, stateful processing is the hurdle you have to clear. It means the system actually maintains knowledge. It keeps a memory across multiple events in that infinite stream. Because think about it, without state, you can't spot patterns. You can't connect a search query with a click that happens 5 minutes later. State is essentially the memory of the stream. And because we have that state, we can actually perform joins on these infinite streams. Let's look at 3 ways to do this. First, a stream-stream join. This is like matching a user's initial search query with the link they eventually end up clicking. Then you have a stream table join, or enrichment. This matches a raw activity stream with a continuously updated user database. And finally, a table-table join. Picture a Twitter timeline. You're joining a changelog of tweets with a changelog of followers to maintain a perfectly up-to-date view. This is exactly how you turn isolated single events into incredibly valuable insights. Okay, Section 3, windows, time, and ordering. This is where things get a bit tricky. To really wrap your head around the headache of out-of-order events, let's talk about Star Wars. In stream processing, you're dealing with 2 completely different clocks, event time and processing time. Event time is when the event actually happened out in the real world, like the narrative chronological order of the Star Wars movies, starting with Episode 1. But processing time? That's when your system actually sees the event, like the real-world release dates of the movies in theaters, starting with Episode 4 back in 1977. If you process your data based on when your machine receives it, rather than when it actually occurred, your data's narrative is going to be completely out of whack thanks to network delays or just random system stragglers. And you can really see the danger of using processing time right here on these graphs. Look closely at this. Say your web server is sending a nice, steady stream of events, but then your stream processor crashes and has to restart. Suddenly, it processes this massive backlog of events all at once. If you're measuring your request rate based on the machine's processing clock, it creates this huge, totally fake spike in your data, which you can see in that middle graph. But if you window based on the actual event time, like in the bottom graph, your data stays completely steady, accurate, and reflects reality. Now, since we're dealing with an infinite stream, we can't just ask the system, hey, what's the total? Because the total is literally always changing. Instead, we have to chop that infinite stream up into measurable finite pieces. We call this a time window. It is the absolute essential tool that engineers use to group, slice, and aggregate continuous data so we can actually pull out meaningful metrics. Things like, average requests per minute.
So let's rapidly run through 4 different window strategies because each one serves a very specific analytical purpose. First up, a tumbling window. This one's simple. Fixed chunks of time, say exactly 1 minute with 0 overlap. Next is a hopping window. This is also fixed, but it overlaps to give you data smoothing. Imagine a 5-minute window that updates every single minute. Then we have a sliding window, which is a bit different. It doesn't use fixed boundaries. Instead, it looks at the actual interval distance between events. And finally, a session window. This one is completely dynamic. It groups continuous user activity together and only closes out when the user has been inactive for a set amount of time.
Let's ground all this theory with Section 4, Real-World Fraud Detection. Imagine that credit card swipe from earlier. Here's how it actually plays out. Step 1, the transaction is ingested as a real-time event into the stream. Step 2, a stream table join immediately fires off, checking a constantly updated local database to grab your typical purchasing habits. Step 3, the processor evaluates a sliding window of your activity over the last few minutes to see if this new location even makes sense. And Step 4, if the pattern looks anomalous, it instantly blocks the card. The whole shebang happens in milliseconds. It's this brilliant micro-narrative of a single event moving through state, joins, and windows just to stop a thief in their tracks.
And finally, Section 5, the future of data.
I want to share this quote from John Gall's Systematics because it's a profound reminder for anyone in engineering. A complex system that works is invariably found to have evolved from a simple system that works. You see, stream processing pipelines can get incredibly complex, no doubt about it, but they absolutely have to evolve organically from simple, reliable foundations. Treating everything as an immutable stream of events gives you that rock-solid foundation. And once you have that, you can confidently build out complex analytics, machine learning models, and real-time alerts. Which brings us to a final kind of provocative thought. Historically, we've always looked at databases as these static tables of current truths, right? But if we really look closely, aren't your databases just slow streams? Think about it. Every write, every update, every delete is just an event. When you start viewing all your data not as static files, but as a continuous, ever-flowing stream of events, the possibilities for what you can build become truly limitless. Anyway, thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you in the next one.